All right, ladies, gentlemen, let's get this going. Notes are a little longer than usual today, or at least definitely longer than they've been. So we're beginning chapter 9 today. Chapter 9 is about quadratic functions, quadratic equations. We've worked some with quadratics. We've factored them. We're going to be using that factoring as part of solving them. So that's a part of what we're doing. A lot of information to start with. First one, a quadratic function is a function with degree 2. So if you have a squared in it, x squared plus 5, x squared plus 2x, x squared plus 2x minus 3, those are all quadratic functions. Standard form. So standard form is y equals ax squared plus bx plus c. A, B, and C are numbers. Okay. A can't be 0, but the other two can.
Why can't A be 0?
Because if it's 0, then we don't have any x squared, so that's not a quadratic anymore. Good question. That's standard form. An example is y equals 2x squared plus 3x minus 4. Now, using the example one, a is 2. A is not 2x squared. A is just 2. How many x squareds do I have? I have 2 of them. A is how many x squareds I have. B would be 3. How many x's do I have? I have 3 of them. And then C would be -4. Not so much for today, but for later on, being able to identify the A, B, and C will be important. Okay. Parent function. The parent function is the simplest form of an equation. The parent function for quadratics is y equals x squared. That's the parent function for quadratics. That is the simplest form of a quadratic equation. You cannot get any simpler than that. Okay? And that's what parent functions are. A parabola. Guys. Parabola, that's the shape of a quadratic equation. It's a U-shaped, that's a parabola. That is the parent function. That is the simplest form of a quadratic that we have. That's the simplest equation. That is the simplest graph of a parabola. All other graphs of parabolas or all other graphs of quadratics are moved left to right or up or down, or they get wide or skinnier. And we're going to work with that over the next couple of days, moving them around.
Oh, wait, did we do this already?
Well, we kind of did a little bit of stuff, but not a lot. Yeah, probably last year. Axis of symmetry. The axis of symmetry is a line that cuts a parabola in half. Not every graph of every type of equation is symmetric. All quadratics are parabolas. All parabolas are symmetric. I can divide them in half. For this equation here, this is my line of symmetry going right down the middle. If I fold it on that line, if I were to take that graph and fold it on that line, the two sides would match up. That always happens with the quadratic. That does not always happen with anything else. Quadratics are rather unique that way, that they always are symmetric. There's always a line going down the middle. There's always a line of symmetry. A lot of other graphs don't have that. They may have it occasionally, but not every single time. Quadratics have them every single time. They're the only one that has it every single time. And then the vertex is the highest or lowest point on the parabola. The vertex is one of the most important points of the parabola. It's the most important part of the graph, but one of the important points of a parabola or of a quadratic is its vertex. On this one, your vertex is right here. It's the origin, 0, 0. That will change depending upon the equation. Okay? Different equations will move the parabola somewhere, your vertex will change. The vertex is the most important part of the graph. Okay? Any questions so far? Got a couple people still writing. Oh, wait a minute. So, standard form of the equation, y equals ax squared plus bx plus c. This a tells us an awful lot about what's going on with our parabola. If the value of a is positive, the parabola opens up, and our vertex will be a minimum value. Minimum value meaning that, remember, this parabola goes on forever going up. It goes up and up and up and up and up forever. It has no ceiling. But it does have a smallest possible point. Parabolas will always either have a minimum value or a maximum value. If the parabola opens up, we have a minimum. This is the lowest point of the graph. Nothing will be lower than that. There will be no y value smaller than this where the vertex is. If a is positive, if the first number in front of the x squared is positive, if my x squareds are positive, it opens up. And my parabola has a minimum value. If my a is negative, the parabola opens down. And I have a maximum value because it opens down, because it has a maximum height that that graph can be. It'll go down forever. Okay, remember, as I keep getting larger values of x, y keeps going down and down and down and down and down. But there is a maximum value that's there. So if it opens up, I've got a minimum. If it opens down, I've got a maximum. So I've got a minimum value here. Y will not get any smaller than that. Here I have a maximum value. Y won't get any larger than that. Okay. That is actually an important thing. All parabolas have either a maximum or a minimum. Okay. And they don't have both. They only have one or the other. Okay. Identifying a vertex. Okay. So problem number one, identifying a vertex. What are the coordinates of the vertex? Okay. So you look at the graph. Remember, the vertex is either the maximum or minimum value. It's either the absolute highest or absolute lowest. I look at this first one here. So your vertex would be right here. What is the coordinate of that vertex? It's 0, 3. Is that a maximum or a minimum? It's a maximum value because that's the highest point, because the parabola goes down from there. It's the highest point. This is a maximum. So on the next one, what's your vertex on the next one? And you should have the graph in front of you on your paper too. Easier to read than this one, I hope. So what is it? What's the what's the coordinate for the vertex on this one? Yeah, 1, -1. And is this a maximum value or a minimum value? It's a minimum because this is the bottom. The bottom is a minimum. Max and min. Max and min. Okay. Those are important. What is your maximum value? What's your minimum value? I want to pause this for a second. So, problem number 2, graphing the equation. Okay, graphing ax squared. So what we're going to do is make a table of values. And I'll have x, and I'll have y. And with our x's, we're going to go 3, 1, sorry, 3, 2, 1, 0. And I'm going to make another table because I wrote too darn big to write any smaller. X, Y, negative 1, negative 2, negative 3. And what's the equation we're using? Y equals 2x squared. This is important that you remember your order of operations when you do these problems. So I have 2x squared. So when x is 3, my y is 2 times 3 squared. What do I do first? Multiply by 3 or square? I square first. Order of operations. Exponents before multiplication. 3 squared is 9 times 2. I get 18. 2 times 2 squared. I square it first. Gives me 4. And then 4 times 2 gives me 8. Then I plug in 1. 2 times 1 squared. Well, that's easy. What's 1 squared? 1. What's 2 times 1? 2. You sure about that now? We can handle 2 times 1? I don't know. Sometimes I wonder. Okay. 2 times 0 squared. What's 0 squared? What's 0 times 2? 0. Okay. Now, when we start putting in negatives, this is a really cool thing about parabolas. 2 times negative 1 squared. What is negative 1 squared? Positive 1. It's 1. 1 times 2 gives me 2. When I put in negative 2, I have 2 times negative 2 squared. Negative 2 squared is positive 4. 4 times 2 gives me 8. And then when I put in negative 3, 2 times negative 3 squared, we've already actually got that number, 18. Now plot the points. Now 318 and negative 318 aren't going to fit on here, but you can get the other ones on. So I got 2, 8, 2, 8, 1, 2, 0, 1, negative 1, 2, and negative 2, 8. These are my points. When you draw a graph of a parabola, remember, it's curved at the bottom. It's not a point. It's a curve at the bottom. Now, mine's a little off because my marker is a little off, writing a little off from where I'm putting it on the board. It's not lining up perfectly. Okay. That's what it looks like. If we were to do and this is kind of important, it's kind of a foreshadowing, if we were to do a regular y equals x squared, the parent function, the one we did by putting the 2 in front, made it skinnier. Okay. So I multiply by a number in front. If it's a number larger than 1, it makes it skinnier. We're going to hit that up a little bit more, I think, on Thursday. No, actually, we're going to do it right now. Okay. So I want to match up the 4 graphs with these 4. It says, what's the order from widest to nearest of the graphs of the functions? And the graphs are all shown. Okay. This is a graph of negative 4x squared. The negative means that it opens down. This is a graph of 1/4 x squared. This is the graph of x squared. Okay. Ignoring opening up or down, which graph is the widest? The second one. What's my equation on here? 1/4 x squared. So this one is the widest, has 1/4 in front. Which is the one in the middle? The last one. Okay. This one is, we'll just call it the middle one because we only have 3. And how many x squareds do I have here? How many x squareds do I have there? I have y equals x squared. How many x squareds do I have? What's my a? What's in front of the x squared? It's 1. Remember, we don't write 1 x squareds. We just, because we're lazy. If I have x squared by itself, how many do I have? I have 1 of them. I'm not writing 1x squared because why would I want to put the 1 in front of something I know there's only 1 of? Yes. So this is the middle one. That's the widest. It's 1/4. This is the middle one. My a is 1. And so obviously this one is my narrowest. And the number in front, I'm going to call it 4, not -4. This is something important to note. The smaller the number in front, the wider your parabola is. The larger the numbers in front, the skinnier parabola is. So if I were to have like 100x squared, the smaller the number, the wider it is. Because look what happened. I have 1/4 and I have 4. 1/4 is big, fat, wide. 4 is skinny. If I were to have 100x squared, it'd look almost like 2 straight lines going up. You wouldn't be able to even see them on this graph. It would be so going up so fast, so skinny, you wouldn't be able to see it. The larger the number in front, the skinnier the graph. The smaller the number, the wider the graph. It's exactly opposite of what you think. Okay? The reason is this one grows 4 times as fast as normal. This one grows 1/4 as fast as normal. The y's are 1/4 what they would normally be. So here the y's are 4 times what they would normally be. No, negative just means it opens down or up. Okay, negative means up or down. We ignore the negative or positive for width. Negative just means it goes down instead of up. Okay. Okay, and our last one, graphing the function y equals x plus 3. Okay. X squared plus 3. We make a table of values on this one. X, y. Let's go 2, 1, 0, -1, -2. Okay. So if I plug in 2 squared plus 3, what do? I square it first and add 3. 2 squareds, 4. 4 plus 3 is 7. 1 squared plus 3, that would be 4. 0 squared plus 3, well, no, it wouldn't be 0. 0 squared is 0, but 0 plus 3 is 3. -1 squared. Notice I'm putting my -1 in parentheses. It's important to do that. -1 squared plus 3 would be, what's -1 squared? No, it's 1, and then 1 plus 3 would give me 4 again. And then -2 squared plus 3. -2, I square that, I get 4. 4 plus 3 gives me 7. Equals 7. Plot those points and draw your parabola through them. So I got 2, 7, and 1, 4, and 0, 3, and -1, 4. And notice I don't even have to, I just kind of match it over. If we were to do 3 and -3, that would be 9 plus 3 is 12. Right? Yeah, 9 plus, yeah. And that would be here and here. So that is the one we did, y equals x squared plus 3. Remember, we have our parent function, y equals x squared. When I add 3, what did adding 3 do to my graph? It moved it up 3 units. If I were to subtract 2, what do you think would happen? It moved it down 2 units. If I add or subtract a number, if I have x squared plus or minus something, the plus or minus just moves the whole thing up or down. That's all it does. Whatever that number is, it moves it up or it moves it down accordingly. So if I were to have one, like I said, x squared minus 2, the graph would be down 2 places. X squared minus 10 would be down 10. X squared plus 5 would move it up 5. Okay? Questions? A lot more notes than we've been doing, but still not that bad. Yes?
Why? I don't get how, even if it's not negative, you still put it on the other side of the graph. Because then you square, like, you know,
Yeah, when you take a negative and square it, what do you get? You get a positive, right? So does that make sense? If I take negative 2 and I square it, what do I get? I get 4. 4 plus 3 is 7. So when x is negative 2, y is 7. This is the thing, and this goes to the symmetry of a parabola. Notice what I have here. 7 and 7. 4 and 4. They match on the either side of it. I have that symmetry that's in there. Because when I square a negative, what do I get? I get a positive. That's why it always either always opens up or always opens down. At some point, you've got a line down the middle. On these ones, my line down the middle happens to be the x-axis.
actually, that's what we do.
It'll get moved sometimes, and that line of symmetry may be somewhere else, but you always have a line of symmetry divides it in half. This one happens to be the x-axis.
Wait, why do you
Okay.
hold the blue line on there too?
Example. As an example, this is the parent function, just to show you what changes are made. When I added the 3, what happened? This is the parent function. This is the basic one. This is the same thing with 3. What is it adding 3 to? It moves the whole thing up 3. Just for a visual adjustment. Does that make sense? Any other questions?